AP Calculus AB, homework 7.4, slope fields. Number one, we're supposed to draw the slope fields for the given differential equation. This one should be pretty easy because it's x plus y. So whatever ordered pair that you have, you add those numbers together and that's the slope. For example, this is 0, 0. 0 plus 0 is 0. So it's going to be horizontal slope. This here is 1, negative 1. So if you add those, you also get 0. 2, negative 2, you add those, you get 0. Negative 1, 1, you add those, you get 0. Negative 2, 2, you add those, you get 0. Let's go right here. 0 plus 1 is 1. Negative 1 plus 2 is 1. Here, negative 2 plus 3 is 1. Here we have 1 and 0, which is 1. Here the ordered pair is 2, negative 1. Add those and you get 1. Let's check out this right here. It's 2 plus 0 is 2, so that's steeper. Here we got 1 plus 1, which is 2. Here we got 0 plus 2, which is 2. We got negative 1 plus 3, which is negative 2. So all of these should have the same slope of 2. If we go in this diagonal, these are all going to be the same. 3 plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. They're getting steeper. No, you're not going to do this perfect. Just make it look steeper than the others. Here's 3 and 1, which is 4. 1 and 3 is 4. And 3, 1, 1, 2, 3. Yeah, that's 4. Here we got 1, 2, 1, 2. So those are both 4, steeper than the 3s. And then here, this ordered pair is 2, 3, so it's 5, so it's super steep. Going along this diagonal, these are all going to have the same slopes. So here we got negative 2 plus 1, which is negative 1. This is negative 1 and 0. This is 0 and negative 1. This is 1 and negative 2, which is negative 1. This is 2 and negative 3, which is negative 1. Those should all be the same, close to the same. You're not going to do it perfect, even though I am erasing mine. Along this diagonal, they're going to all be the same because each of those ordered pairs are going to add up to the same negative 2. So let's say negative 2, negative 2, negative 2, negative 2. This diagonal, they're going to each add up to negative 3. So it's more steep negative. This diagonal is negative 4. And this one's negative 5. Slope field looks something like that. Do your best. Number 2 is more complicated. Number 2 is definitely more complicated. So let's see. See if we can find some patterns in this. So I'm going to make a table of values for this because I'm anticipating this giving me some problems. In each case, we are supposed to take and make this negative y over x. So for example, let's just start right here at the origin. Whoops, sorry about that. Here at the origin, I'm going to have the ordered pair 0, 0. And that's going to translate to me having negative 0 over 0, which is undefined. Undefined slope means it's vertical. So that's going to be vertical right there. What if we go 0, 1? It's going to be the same because we're going to have negative 1 over 0, which is undefined. Hopefully you can see the pattern here. If I pick an x value of 0, it doesn't matter what I choose for y, it's going to be undefined. So if my x is 0 and my y is undefined, it's going to happen on the y-axis. All these slopes are vertical because they're undefined. Vertical line has an undefined slope. So I found that pattern pretty quickly. Let's see, what about, let's say that we choose a y value of 0 and we choose x to be whatever we want, other than 0 for x. In each of those cases, you're going to have negative 0 over x, which is 0 over x. 0 over x is going to be 0. So that means on the x-axis, slope is 0, slope is 0, slope is 0, slope is 0. Wherever these conflict, which is here, we're saying it's undefined and slope is 0. Undefined wins that war every time. Let's see if we see any other patterns here. Let me choose. Let's go down and choose x values of negative 1. So that's here. All these places x is negative 1. So if we choose negative 1, 3, that's going to be negative 3 over negative 1, which is 3. If I choose negative 1, 2, it's going to be negative 2 over negative 1, which is 2. I'm seeing a pattern. If I choose 1 for y, it's negative 1 over negative 1, which is 1. So my slope is 3, and then it's 2, and then it's 1, it's 0. The next one's probably going to be negative 1, and then negative 2, and then negative 3. Let's just check to make sure. If I go negative 1, negative 1, it's going to be a negative 1 over negative 1, which is negative 1. If I go negative 1, negative 2, it's going to be negative 2 over negative 1, which is negative 2. Yep, this pattern is working. So I'm going to cut that out there. What if I go with positive ones? I want to see what's happening here. So notice if it's positive ones, you're dividing by 1. It has no effect on the problem. It doesn't do anything. So essentially, if I choose 1, y, this is just going to end up being the negative y value. Just change the sign. So for example, if I have 1, 3, it's just going to be a negative 3 over 1, which is negative 3. You know what? I take that back. No, I don't take that back at all. So that's negative 3. If we put a 2 in, it's going to be a negative 2. Put a 1, it's going to be a negative 1. If you put a negative 1 in, you're going to get positive 1. You put a negative 2 in, you're going to get positive 2. Put a negative 3 in, you're going to get a positive 3. Now let's continue. We got a lot more to do. You can see how tedious and stupid this becomes. Let's go ahead and try this column. In this column, our x values are all 2. Let's see what happens with the y values. In each case, once again, it's negative y over 2. So like here at 3, it's going to be negative 3 over 2. At 2, it's going to be negative 2 over 2, which is negative 1. At 1, it's going to be negative 1/2. So we got a slope of negative 1, slope of negative 1/2, slope of negative 1.5. As we go down here to the negative y values, say like negative 1, you're going to have a negative negative 1, which is positive, so we have positive 1/2. And then if we have 2, negative 2, it's going to be 2 over 2, which is 1. And then 2, negative 3, it's going to be 3 over 2, that's 1.5. Still have this column over here to do. And in those cases, the x value is negative 2 each time. So that means if we have negative 2y, and this is a negative y over negative 2, those cancel. So essentially we're saying negative 2y is just going to be y over 2. Just take the y value and divide it by 2. That's what we're saying. So here, 3 divided by 2 is 1.5. That slopes, there's 1, maybe there's 1.5. Here the y value is 2. 2 divided by 2 is 1. And then here, the y value is 1. 1 divided by 2 is 1/2. Here we're going to have negative 1/2, negative 1, negative 1.5. Slope field is going to look something like that. Yours is not going to be perfect, and mine certainly isn't. Number 3, this one shouldn't be too bad because there's no y's in it. Just whatever x value you have, you add 1 to it. Y has no effect. So for example, for all these x values here, which are negative 2 are the x values, we add 1 to those. Negative 2 plus 1 is negative 1. So all these slopes are negative 1. Just going to throw those in here. Lovely. Well, this column here, all the x values are negative 1. Negative 1 plus 1 is 0. So each of these have a slope of 0. This column, all the x values are 0. 0 plus 1 is 1 every time. So all these slopes are positive 1. You are just estimating what you think this slope looks like. Make sure you get the positivity or negativity correct. In this column, the x values are 1, and it's 1 plus 1. That makes that 2. So I know it's steeper than the previous one. Try to make all these as same as I can. Yes, this is a pain in the rear end. Yes, this seems silly to do by hand. But we're being asked to do it, so we're going to do it. This next one, these x values are 2, so it's 2 plus 1 is 3. These are positive and they're more steep than the previous one. Try to make them as consistent with each other as you can. This is a slope field. These are all representing parabolas. We know that because the antiderivative of this is a quadratic. Just pointing this out, each of these represents a parabola. Each of these represents a particular solution to this. Because if I were to draw each of those graphs, those little tick marks that I have there represents the slope of the curves as we continue, whatever that does for you. All right, the last one we got to draw by hand in this assignment. Praise the Lord, huh? Praise the Lord. This one looks a little tougher. There are no y values. We can ignore those, and that means that each of these columns that we have here are going to be the same slope in each column. I should have chose a different color. I'm just going to color these up so I can point out a column and then discuss it. So for example, let's take the column that's green, where the x value is -1. If x is -1, then the slope is going to be, I'm sorry, I want to do -2 first. It's going to be -1 because -2 minus 1 is -1. So all these slopes are the same, -1, -1, all the way down. What about when x is -1? Well, if x is -1, we're going to have 1 over 0, which is undefined. And I've seen this both ways. I've seen this undefined being there's nothing there, like you don't graph anything. And then other times I see them graphing these verticals. I think both are acceptable. Hope they are. For the purple column, that has an x value of 0. So y prime is going to be 1 over 1, which is a +1 slope. Same thing all the way down through this column. And then for x equals 1, y prime is going to be 1 over 1 plus 1. That's a half. So this is starting to flatten out some. And then when x is 2, y prime is going to be 1 over 2 plus 1. That's 1/3. Flatter still. This is far from perfect, but it would be clear to anyone that looks at this, this is a flatter slope than the previous column. There you go. For number 4, we are supposed to match a slope field to a solution to a differential equation. So we have solutions. We are matching solutions, not differentials. When given a slope field and a solution to a differential equation, then the slope field should look like the solution y. So I've already taken the liberty of showing you, of matching these together. There's no work to do for this. You just have to know that y equals c is a line. It's a particular solution. And the line has slopes that are consistent all the way through. That's why I chose C for that. Number 2 is a parabola. It's a pretty basic parabola. Y equals x squared. It might look like that. 3 is an exponential function. And if you can see here, these curves sure look like they are exponential curves. 4, I chose D. 1 over x squared has a vertical asymptote and a horizontal asymptote. It looks something like this. 5, I chose H because it's cubic. Cubic function looks like this. Probably shouldn't be using a highlighter. Something like this. 6 is a sine graph. We can pick out like so. 8 is a cosine graph. cosine has a y-intercept of 1 for the parent graph. It looks something like, whoops, something like this. 8 is a radical. This one's pretty tough to see. Maybe something like this. 9 is y equals 1, slopes 0. There's a bunch of horizontal lines. That one's probably the easiest. And then tangent, if you recall, looks like this, and it has vertical asymptotes. That's why I chose I for number 10. So hopefully that was helpful. That concludes the homework.